Next theorem. The only divisors of 1 are 1 and -1. And -1. Okay, very good. We're going to prove the only divisors of 1 are 1 and -1. Okay, very good. Let us try to prove these statements. What's the definition of divisor? D divides n if and only if n can be written as d times k, k belongs to z. So let's follow the definition for now. By definition, if d divides 1, 1 is written as d times k, and k is an integer. Guys, remember that. D is also another integer, and d cannot be 0. Well, you have 1 equals to d times k. Both of these numbers are integers. 1 is equal to d times k, and d and k are both integers. So what options do we have? 1 can be written as 1 times 1. 1 can be written as -1 times -1. We only have 2 options. So d is 1, k is 1, d is -1, k is -1. But is that enough? Unfortunately, it's not enough. We just showed that 2 possible numbers as divisors for 1 or 1 and -1, but it's not the definite step. We are not going to stop at this point. We need to show that there is no other divisor. So suppose you found another divisor. Suppose you found another divisor. Another divisor. Like what? Like m. That divides 1, but m is not 1 and m is not -1. This is the assumption. What can go wrong here? M divides 1, A divides B from previous theorem. If A and B are both positive, we know that by previous theorem, A is less than or equal to B. Okay, take a look at this. So M divides 1, and consider the case that M is positive. If M is positive, then by previous theorem, then M is less than or equals to 1. Okay, m is an integer. M is positive, m is less than equals to 1. So the conclusion says, hey, m must be 1. There is no other option. In the case that m is another divisor, divides 1 is a factor of 1. And in the case that m is positive, then by previous theorem, we just proved that a must be less than equals to b, or m is less than equals to 1. But you have a positive integer that is less than or equals to 1. There is no other option. M must be equal to 1. Okay. Now let's check the last scenario. Now, if m divides 1, then 1 can be written as m times n. N is another integer. M times n is equal to 1. And suppose the case that so m was positive, m was equal to 1. If m is negative, then negative m is positive. Very good. If your m is a negative number, m times n must be equal to 1. What's the meaning of that? It means that n must be negative as well. And also, then n must be negative as well. So what happens here? M times n is equal to negative m times negative n, which is equal to 1. So we end up with the same scenario. Your divisor as negative m is positive divisor. So negative m must be less than or equals to 1. So m must be negative 1. Very well. So in either case, we showed that any other divisor doesn't have any other choice. It must be 1 or negative 1. So we're done with the proof.